Good morning, dear students. In the last class, we have gone through the so many concepts here. So I have started the chapter number 2 for you people, and also the chapter name is units and measurement. And we have gone through what is physical quantity, types of physical quantity, what is a unit, then system of units, then SI system of units, and what do you mean by radian, and also steradian. So later on, you have studied the multiples and submultiples concept. I think you are clear about that. So better you go through that once again. So next concept, let us move on to the parallax method. What is a parallax method here? So see the definition here. I'm going to highlight. See, you can see here the relative shift in the position of the object with respect to the background. So the relative shift in the position of the object means, so for example, when we see the moon by standing on the earth, we feel that it is so near. But when we find the distance, it will be too far only. For our eyesight, it will be looking, the distance will be varied, that we feel like it is very near to us. So let us go through the definition now. The relative shift in the position of the object with respect to background means, when we see from our own eyes, there will be in the shift of the position with respect to background means with respect to the original. Here respect to background denotes with respect to the original distance here. So there will be some of the difference to what we observe and also actual distance. The relative shift in the position of the object with respect to the background. Here respect to the background refers to the original value. So next you can see here I have written basis. Let me go to the diagram first here. So you can see here A, B. Here A is the first position on the earth. We are standing there and we are observing the, you just think we are observing planet. Here B is the second position. From there also we observe the planet and we measure the distance. So let me just take this point as here P. So P means planet. So that was missing in the diagram. Here P means planet. So capital D is the distance from the earth to the planet or earth to the star here. So here theta is the parallax angle. It is made because of the position A and the position B here. A is the position number 1 and B is the position number 2. So because of those two, the theta is made, that is the parallax angle. Here capital D is the distance from earth to the planet or earth to the star. So go to the next slide. In the above figure, theta is the parallax angle. I have already said you that is theta is the parallax angle. Capital D is capital D. What does capital D denote here? Capital D is the parallax angle. Let me highlight. Here capital D is the distance between the planet or star and the earth. It is distance between the earth and the planet or earth or the star. Here B is the basis. What is the basis? Here basis means it is the distance between the two positions. In diagram you can see here A and B. Observe here. Dear students, you observe here the points A and B. You can see here, I'll highlight the points A and B here. So those are the 2 points. So the distance between those 2 points itself is known as the word basis. So next here, B is the basis and B is very less than D means here capital D, you know that the capital D means here the distance between the planet or the distance between the star to the earth here. So when this basis becomes very less than to the capital D, when basis becomes very less than to capital D, the theta, the angle theta becomes small. When the basis becomes small means when the distance between A and B becomes less, very compared to the distance between the planet and the earth, then angle theta becomes small. So here, as I have told you now earlier only, A and B are the positions of the observation on earth. So assume that, go back to the diagram here. So assume that we are drawing the circle by assuming this point P, by assuming point P by assuming point P as the circle, center of the circle. But I am drawing the circle by assuming point P as the center of the circle, and at that time this observe that B. What is that B? That is basis. But if I draw the circle by assuming P as the center of the circle, then that basis will become arc length, and this capital D will become the radius. I am doing in order for calculations. And here what I am finding in this parallax method is I am going to find the distance between the earth to the planet or earth to the star here. So capital D becomes radius when I assume that P is the center of the circle. If I draw the circle by assuming P as the center of the circle, then the small letter B basis is known as the arc length, and then this capital letter D, the distance between the earth and the planet or earth and the star, that becomes radius. So later on, so I have put the another diagram so that you will understand here. Then after drawing the circle, the B becomes arc length and the D becomes radius. I am repeating once again, P becomes the center of the circle. So I need the parallax angle. If I want to take the expression for parallax angle, how do we define angle here? Arc length, how do we get the angle here? By dividing the arc length by radius. So arc length is, after drawing the circle, the basis B becomes arc length. Before drawing the circle, B is the basis itself. But after drawing the circle, by assuming P as the center of the circle, then later on D is the radius of the circle here. Then after taking the expression, theta is equals to arc length, that is B divided by capital D. But I am calculating here the distance between the planet and the sun, or distance between, sorry, planet and the earth, or distance between the earth and the star. So I want the expression for distance, so that if I take the expression for distance, I'll get D is equals to B divided by theta. So this is the procedure in the parallax method, that is how we calculate the distance between the planet on the earth or star and the earth. So this is the one method. So I told you, for measuring small lengths, we use vernier calipers, screw gauge, sperometer, electron microscopes and everything. But here, to calculate the bigger lengths, this is the method which we use, that is parallax method, in order to calculate the distance between the earth and the sun, or earth and the moon, or earth and the star, etc. So let us go through the next derivation. In this diagram, derivation, what I am doing is, first I found out the distance between the planet and the earth. Next I am going to find out the expression for diameter of a planet from the earth. So here, finding the expression for diameter of a planet or moon, in diagram you can see here. So here planet I have taken, I am highlighting, this is the planet, the circle represents the planet. Here A and B, points A and B are there, you just observe that. Later on I have written the explanation in the next slide. Here capital D, here angle is taken as alpha. So here that O denotes the earth. So let us see the explanation. So in the above figure, small letter D is the diameter. Small letter D, that is, I'll show you here. The small letter D you can find out in this figure. Just to see here, this is the small letter D. So this is the diameter of the planet. So small letter D is the diameter of the planet. Here A and B are the opposite points of the planet. So A and B are the opposite points of the planet. So small letter D is the diameter of the planet. Here A and B are diametrically opposite points of the planet, as I said you. Here capital D is the same as last derivation, that is distance between the planet and the earth. Alpha is the angular diameter. Alpha is the angular diameter of the planet. In the last derivation we have taken theta as the angle. So as small letter D, that is diameter of the planet, if at all the diameter of the planet is very, very less than the capital D, diameter of the planet is very, very less than the capital D, means diameter of the planet, when it becomes very less to the distance between the planet and the earth, the angle alpha becomes small here. So in the last derivation also, we have assumed that we will draw the circle. So if I draw the circle by keeping, once again, let me move here. If I assume that O is the center of the circle, if I assume O is the center of the circle here, and if I draw the circle, then what will happen? The small letter D in the diagram becomes arc length. Then P becomes the center of the circle. In the last diagram, I have taken as the O, so don't get confused. And here capital D becomes last, it was distance of the planet, but now after drawing the circle, it becomes the radius of the circle. So I'm taking the expression for angular diameter, that is equals to arc length by radius. But here I'm for if I take the expression for angular diameter, I'll get alpha is equals to small letter d divided by capital letter D. But I want the expression for diameter of the planet, so that I'm altering the expression, and I will get small letter d is equals to alpha into capital D. So these are the two derivations. In the first derivation, we have calculated the distance between the earth and the planet, or earth and the star. In the second expression, what we have found out is the diameter of the planet from the earth, or diameter of the moon, by using the parallax method. So these two are the important derivations. So any one of the derivations may occur in your examination. So let us go to the next point. What is a light year? What is a light year? So light year, it is the distance. It is the distance traveled by the light. It is the distance traveled by the light in 1 year. So ಒಂದು ವರ್ಷದಲ್ಲಿ ಲೈಟ್ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ನ ಟ್ರಾವೆಲ್ ಮಾಡುತ್ತೆ ಅದನ್ನ 1 light year ಅಂತ ಹೇಳ್ತೀವಿ. In a single year, how much the distance the light travels itself is known as light year. So the value of 1 light year is equals to 9.46 into 10 raised to 15 meter. So that is the value of 1 light year here. So next, let us move to the astronomical unit. What is an astronomical unit? So it is the distance of the sun from the earth. It is the distance of the sun from the earth. Light year is the distance traveled by the light in 1 year. So that value you can see there. Astronomical unit means it is the distance of the sun from the earth. The distance of the sun from the earth is given the name as astronomical unit here. So value of 1 AU. 1 AU is AU means astronomical unit. 1 AU is equals to 1.49 into 10 raised to 11 meter. So next concept I have taken as parsecond. So that is another value, so another unit for the to measure the distance of the sun from the earth. So if I want to convert the light years value in terms of if I want to convert the parsecond value in light years. So parsecond is the another unit for another unit to measure the distance from the distance of the sun from the earth. So if at all I want to convert, from parsecond to light years, so I have put just a diagram to make you understand here what is the 1 parsecond distance. See the diagram here. So this distance is 1 AU. The angle made here is called as 1 parsecond, and the vertical line that gives 1 parsecond. So if so 1 parsecond value is, so these are the different units which I'm not going to drag so much. So 1 parsecond, it is another unit. So 1 parsecond is equals to 3.086 into 10 raised to 16 meter. So if I want to convert the parsec value to the light years, so I have to divide the parsec value. So I have to divide the parsecond, we can call as parsecond also, parsecond value by the light years value. So what do I do is, so already know that what is the parsecond value, that is 3.086 into 10 raised to 16 meter divided by 9.46 into 10 raised to 15 meter. So if I divide that, I'll get 0.3262 into 10 raised to 1. So if after shifting the points, so I'm shifting 0 point here, see 1, so that will be 3 points. So 10 raised to 1 will go, so 1 power I have to shift, so that it will become, see, 3.262 light years. So I'm doing this whenever I want to convert the value from parsecond value to light years, I have to divide those values so that I will get the answer. So the next concept is measurement of mass. So mass of a substance. What is a measurement of mass? Mass of a substance is the amount of matter present in it. So yes, I have already discussed this with you. SI unit is kg, and the mass range also I have told you, that is 10 raised to minus 30 kg to 10 raised to 55 kg. To measure atomic mass, unit used is atomic mass unit, AMU. To measure the atomic mass, the unit used is AMU. So value of 1 AMU will be how much? That is 1.66 into 10 raised to minus 24 kg. That is 1 AMU value. This value can also be called as the mass of carbon 12 isotope. So measurement of mass is this much. So how do we measure the measurement of time? So time is measured in clocks, and time ranges from 10 raised to 22 seconds to 10 raised to plus 18 seconds. So cesium atomic clocks is used to measure the time. It is also used. So cesium atomic clocks are used to measure the time. So these are the concepts which we discussed in our today's class. We have discussed what is parallax method. It is the relative shift in the position of the object with respect to the background. You may arise with the doubt that why we are observing from the 2 points, because when we observe from the far, we cannot get the correct distance from the earth to the planet, so that we are observing from 2 points, that is for example A and point B. If we do the average, at least we can get the nearer value, so that we are using this method. And next we discussed is to calculate the diameter of the planet. Go through the video again and again, see the diagram so that you can easily understand. Then I told you what is light year, what is astronomical unit, and another unit of the which is used to measure the distance of the sun from the earth, and how do we convert the parsecond value to light years, the measurement of mass, some of the points I mentioned, and the measurement of time. So dear students, I'm going to end up this today's class at this point. So in the next class, I'm going to explain you the dimensions, which are very important in this chapter. So let me wind up today's class. Thank you.